For question 13, to understand the setup, we explained that in the previous video for question 12. Please go back and view that. So now we're talking about after the cylinder leaving the table, which is the pink part that we're talking about. The rotational kinetic energy and the translational kinetic energy. We could start with either one, but we may start with the translational kinetic energy. What we know in the beginning when that cylinder leaves is that there is a component V, Vx. And the component in the vertical direction is 0. And as that cylinder travels, Vx is going to remain constant, but there will be an increasing vertical component, Vz. So overall, what will happen to the translational kinetic energy is it must increase. Vx remains the same and Vz increases, so the translational must increase. So by that token, then, we can eliminate choice B, where it stays the same, and choice D, where it stays the same. The next question is, what happens to the rotational kinetic energy? Now, for the rotational kinetic energy to change, the rotational kinetic energy is 1/2 I omega squared. Now, the I will remain the same, the moment of inertia. The question is, will omega change? For omega to change, for there to be a delta W, there must be an alpha. Alpha is a rotational acceleration, which is delta omega over delta t. And as you remember, a net torque produces a rotational acceleration. So there must be a net torque for there to be a non-zero acceleration. If the net torque is 0, the acceleration will be 0. If the acceleration is 0, the omega will be 0. And if the delta omega will be 0. If delta omega is 0, then the rotational kinetic energy remains the same. So the question is there a net torque acting on that body? Now, as the cylinder is rolling down the hill, there is a frictional force that is providing the torque. But when it's in the air, there are no rotational forces acting on that body. Again, as we are rolling down the inclined plane, there is a frictional force acting in that direction. So there is an RF. When it's in midair, there is no force that is acting as a torque. So that means the net torque is 0, the alpha is 0, the delta omega is 0, so the change in kinetic energy is 0. Therefore, the rotational kinetic energy remains the same.